right, so this is the 12-1 activity. This is going to finish up this section, and you should have already worked through the worksheet and given it a try. This is like our equivalent of Fun Friday, except it's fun whatever day it is out there in your world. So let's go ahead and look at that worksheet. I should know how to do this by now, huh? Okay, share screen. Here we go. And what we have here is a table, and we are given this line of best fit, and it says according to the line of best fit, what would be the predicted number of coffee sales? So again, I'm just going to go through this quickly. I'm not going to read every problem. I'm just going to go through the solutions because the theory behind it is you've already done this and you're just coming here to check and make sure you're right and get an explanation if you are not right. So this first one, we have we're going to use the line of best fit, which is our y hat, and we're going to plug in 32 degrees into this problem, and when you plug that into your calculator, it says round your answer to 2 decimal places, we're going to get 63.34. Now it says, what would the predicted number of coffee sales in hundreds of dollars be for, blah, blah, blah. So I don't need to convert this into hundreds. This table is in hundreds of dollars. They ask for the answer to be in hundreds of dollars. I look at the table, I see a 65, a 58, a 50, and so forth. And so this number here fits right in to this table. So in terms of adding the hundreds of dollars, we don't need to add that because it asks for the answer to be written that way. Okay, so going to the next problem. Now, we have the age of the person in years, and we have the coffee sales in hundreds of dollars. I think what happened here was I was trying to not have coffee sales for every example, temperature and coffee sales, and then I kind of got distracted. So I changed half of it into age, but I forgot to change the other half. So I don't know why we're talking about age and coffee sales, but that's my best guess. I think I was watching Transformers at the time when I made this. Okay, so we have the person's age, and it says the person who's aged 45 degrees, the prediction would be 57:30. Is it reasonable to use this line fit to make this prediction? So remember, we have reasonable and we have reliable. This question is it reasonable? Does it make sense? So 45 is over here, and we have an answer of 57, and yeah, that seems to fit into this pattern here. I don't have a reason to believe that it wouldn't. And then as you look through the answers talk about if it's reasonable and if it's reliable. So first of all, it seems reasonable. All these answers are between 40 and 68. So an answer of 57 does make sense. So it is reasonable. I'm going to cross off those two choices that say unreasonable. So now the difference between the top and the bottom is reliability. Yes, it's reasonable that a 45-year-old would spend $5,700. Okay, it's a little silly, but anyway, let's just say, according to this chart, it does seem reasonable. Is it reliable? That is 45 years in between our scope? So our scope goes from 40 to 70 years old. And 45 is right there, but it's inside that scope of data. So it is reasonable and reliable. Reliable, remember, that is within the scope. So it is within the scope of data. And one thing I want to emphasize is the scope of data, the reliability only depends on the x's. I can't control what the answers are. That's why they're dependent. They depend on what the years are, right? I can't control the answer to how much coffee is being sold for a certain age, but I can control the age I'm predicting about. So if I'm predicting between 40 and 70-year-olds, I can definitely make a prediction about a 45-year-old. I cannot make a prediction about a 35-year-old or a 25-year-old or an 85-year-old. Those people are all outside of the scope of data. But I can make predictions based off of this chart from 40 to 70. Okay, number 3, we have X, which is the student's actual grade level, and Y is their grade level on a reading test. And so we want to find the regression line for the data values. So just a reminder, that line is the formula y hat equals ax plus b. And you want to use your lists, L1 and L2. And you want to use, on the calculators, on the scientific calculators, you want to use 2 variable stats to look for A and B. So this one would be scientific. And then for the graphing calculators, you're going to look for that it says linear regression AX plus B button. And that's under the calculate menu. And then you'll also look for A and B on that. If you have any calculator questions, either email me or come to my office hours, show me your calculator on the screen. A third option, if it's midnight right now and you want to have an answer right now, Google it. Just type in the type of calculator you have into Google and say, how do I do linear regression on whatever calculator you have. All right, so what you get after you put it, there's nothing to do here. It's just this purely a calculator problem. It says round to 2 decimal places. So here we go. I wrote those backwards. 3.9. And that is the answer to number 3. Backside, number 4, we have this picture, and we're just talking about what kind of pattern you can see going here. So I definitely have a pattern. This looks a little more organized than someone just dumping pepper on my screen. So I have this, I'm noticing this downward pattern, and it looks pretty linear. Well, actually, all my choices are linear. So it's definitely not no pattern, because no pattern would just be a scattered mess. Because it's headed down, it would be negative. So my positive choices are off. And then linear, or linear with deviations. Well, since I do have a few points, well, those points definitely are jumped out. But even here, I have a few points here and there that don't exactly match up. So it's definitely has some deviations. It doesn't have a lot, but it has some deviations. All right, number 5. And this one, people get mixed up on sometimes just because of the 50. And so this right here, we have the percent of items on sale is our X variable, our input, our independent variable. That's what you can, the store can control. They can control how many items are on sale. And then over here, we have the percent of purchases over $50. Now, they can't control how much people spend, but they can control what's on sale in their store. And so this $50 listed in the problem, that's just talking about the Y variable. So we're going to use this line. So the owners collected information from 6 stores, definitely a scatter plot, but we see a positive linear pattern with some deviations. And we want to estimate the percent of purchases over $50. So we want to estimate, right here is Y. We want to estimate Y if X equals 45% of the 45% of the items are on sale. So I go to my X. I'm going to follow this up. Then we're just estimating. Right up to my line. There's the point. That point, X is 45. What is Y? So we're going to come over. It looks like I kind of covered up everything with these big fat pen that I have. But it looks like maybe 54%. Maybe you said 53. Maybe you said 55. Somewhere around there. But it should be within that rate. If you said 60, you're off. You want to be between 50 and 60. In the middle there, about 54 to 55%. We have a lawn mowing service. She charges $90 plus $65 per week. And so I wrote out the equation of the line backwards, just so you don't always put the first number down for slope. And then we have the independent variable and the dependent variable. So let's just, since I said slope, we'll jump to the bottom here. The slope is going to be 65. There's no x in slope. So just put the numbers in front of the x, which is 65, which means the point 090 will be our y-intercept. So 90 right here, at the second part of the problem, or I guess that's the beginning of the problem, we have, that's the y-coordinate of the y-intercept, and then the 0 is the first, is the x part. Okay, so now we have two things going on. We have how much money Isabel's making using that formula, and then we have this hour of how many hours does she work. So that, I just circled the air right there. We have the hours of work, and then we have the total amount of money are the two things in this equation. And so the independent variables, that's going to be what she can control. She can control how much hours she works. So that's going to be the amount of time Isabella works. Or in other words, the hours. And then the dependent variable, that's going to be what she's calculating. When she goes to figure out your bill, she's going to plug in how many hours she worked, and then she's going to tell you that dependent, that output variable, is going to be the amount of money Isabella makes. An amount of money, of course, that's going to be dollars. And so I keep using these words interchangeably, but independent, that's X. Dependent, that's Y. Independent is the input. Dependent is the output. So this all goes back to those graphs that we have been talking about. We have been talking about since pre-algebra. That is it for this worksheet. I hope you got 100%, and I will see you in 12:3. I should have timed that a little better, so I ended it right at the right spot. Okay, I will see you in 12:30.